Hello everyone, welcome to my channel. So today we're going to do the slope stability analysis using GeoStudio's Slope W module. Whether you're a student, engineer, or a researcher, this guide will definitely help you understand the basics of assessing or evaluating the slope stability. It's a pretty powerful software, and in today's tutorial, we'll walk you through setting up the project. We will be defining various materials. We will be sketching the slope scenarios, and we will be applying boundary conditions, and then we'll be analyzing the slope using different methods. So by the end of this video, you will have a clear understanding of how you can perform a limit equilibrium analysis and how you can interpret the results effectively. So let's have a look at what is basically the slope W module, or GeoStudio's slope W module. So basically, yes, GeoStudio is a pretty powerful, comprehensive software. It is being used by most of the geotechnical engineers around the globe, and it is best an area for analyzing slope stability, for simulating the groundwater flow, stress conditions within soil and rock. It allows users to model complex geotechnical projects including excavations, embankments, dam, and mining operations by combining various analysis methods like limit equilibrium, finite element, and stress-based stability analysis within a single platform. So it's pretty useful tool, and it is best that if you understand all the things about this tool. So this GeoStudio has various key modules. It has a slope W module that is used for analyzing the stability of embankments, artificial dams, natural slopes, and it has Seep W. As the name suggests, it is used for a finite element analysis of groundwater flow, if you have poor water pressures, and if you have saturated soils. And it has sigma W that is used to conduct the finite element and deformation analysis of soil and structural materials. And then we have quick W that is for the seismic to test the seismic stability of the slopes, and you can induce the liquefaction in it, and it all does the analysis using finite element methods. There are some other GeoStudio modules like temp W, air W, and citron W. These are some advanced sort of modules. So we'll stick with slope W, and here is a sort of slope that I had analyzed, and you will be drawing this diagram using GeoStudio. So that's the introduction. I think we should move to the software to see how we doing. So let me just show you what sort of example we will be doing today. Here is the example. We will be solving the slope. Here is the example. It's a normal sort of pretty easy example, just for the beginners. Wait a minute. Okay, so what you can see is these are the coordinates. One of the very important aspects that you need to do in these geotechnical software is that you have to use the coordinates to draw the regions. So for this region, that explains this is our soil. So if you can see is that for this region we have to use these coordinates to draw this region in our these are the soil properties that are being given, and they have given us the unit weight, the cohesion, and the angle of internal friction. And along with that, they've also used the slip failure plane. That's the slip failure plane. That's the center coordinates of this plane here, and this is the radius. So we will be using all this information and inputting them into the software. So first we'll go to the to file and make a new project here. Uh, when you click on the file and go to new, it will take you to this home screen, and here the option is that whether you have to go with imperial units, that is in feet and pounds and things like that, and in metric you will have newtons and kilonewtons and meters. for the length. So, and this is this paper size, so we'll go with metric A3. It all depends on your project requirements. So we'll go with metric and A3. So we'll click create, and after creating we'll have this uh, define project dialog box. So we'll go with 2D analysis, and once you add the 2D, it will ask you about the various sorts of analysis you want to do. We'll go with slope W, and we'll take the limit equilibrium analysis. That's one of the basic things. It will ask you about the license to be activated, so click OK, no problem. Now once the license will be activated, it will give some basic these are some of the basic options available to you. It includes the what sort of site function you have. It doesn't matter. And then we have the pore water pressure, but this all depends on what sort of analysis type you have opted or chosen. So because we have to go with a very basic Bishop method, so we'll be using the Bishop method of analysis of slope stability. And we don't have any pore water pressure condition here. And also one important thing that we need to look for is about the slip surface, whether we have it's from left to right or right to left. So if you're gonna look at this slide, you'll see that we have two sorts of slip surfaces available that we can choose. So it all depends on the it all depends on what sort of project you're doing. So for this case, you see that it is from right to left. That means that the failure will be like this here. And you can see that in case of left to right, the failure will be like this. So you can see that in this case the failure will be like this, but in this case the failure will be like this. So it is from left to right in this direction, and in this case it is from right to left. So, or if you look at our example, you can see that this failure will be from right to left like this. So we'll be choosing the right to left here. Okay, so no problem. We don't need to change any other options here. Those are some sort of complex things, so you can just click close. So the first thing, the one of the very basic thing you need to do is you need to draw your axis. So you'll go to sketch. So for the sketch, for the axis, you will see what sort of what sort of lengths you have. So if this is our x-axis and this is our y-axis, so you can see that we have our x-axis at 35 meters and y-axis is maximum of 17.5 meters. So we will go with 35 on x-axis and 17.5 meters on y-axis. And make sure that once you enter the values, make sure that you have both elevation and distance is enabled. So we'll have elevation and distance. So we have just made the axis for our project. So once you have done the axis, the next option is you need to define the points that you have, and you'll click. So what you need to do is you need to go to define, and then you need to go to the points, and within points you can enter all the coordinates you have here. So you'll start from here, and then you'll be adding all A, B, C, D, E, and F. So we'll be moving from 0 0 here. These are 0 0, and then you can just click and use the tab button to quickly shift from one value to the other. The next one is 0 to 10, so 0 10. The next is 10 10, so it is 10 10. And then you'll have this 25 and 17.5, 25 17.5. The next is 35 17.5, and the next is 35 0. So we're done. You can click close. You can see that we have all these points are well defined. Once the points are well defined, you can draw the region here. So you'll go to draw in regions. Now in this option we will be drawing polygonal. You can just click the points here like this. One by one we will draw all these to make a region. So the region has been made, but we have not assigned any soil to this region. So for that you have to first define your materials. So you'll go define and then click materials, and then you'll have to add a material. So we will name this material as like sandy soil maybe. You can also change the color. We'll keep it as default. And for the material model, we'll go to the Mohr Coulomb model. That is the most basic model normally used. So for this we have basic options that we have to define, like unit weight, cohesion, and angle of friction. So we'll have unit weight gamma, that is 20. Then we have the cohesion, that is also 20. Effective cohesion is also 20, and the angle of internal friction, that is also 20. So we'll do this, and once we have done all these values, we can click close, and then our soil has been set. But because the soil has been defined, but it has not been applied, so for that we have to go to draw, and then we'll go to materials, and you can choose the sandy soil here, and then all you need to do is go to the region and go to anywhere in between the region and just use the left click to assign the sandy soil to that region. So we'll left click, so you can see that the color has been changed, color has been matched with the color that you have opted for in the material. So the material has been assigned, and yeah, we are all done except one thing, that is if you'll start the analysis at this stage, it will give you an error of the slip surfaces. So what you have to do is go to this draw and then go to slip surfaces, and then what does this mean by the slip surface is actually that that you have to draw the entry and exit of this slope failure. What does it mean is that if you can see that if this is our slope, then we have to first draw that from where the slope failure will enter. Like if here is the entry point, then we can say that this is the entry point of the failure. The failure can happen anywhere along this line, and the exit is that the exit of the failure can be anywhere along these lines. So that's the basic thing we do normally in the analysis. So we'll have to go to the define draw, and then we have to go to slip surfaces. So we'll just go to draw, and then we'll go to slip surfaces, and then entry and exit. So it will ask you about the exit range on the left side and then entry range on the right side. So our left point for the left range will start from here. Uh, Then let's say here this is the point that where it will enter. Enter. Exit range is the left side slide, and then entry range for the right side. So for this we'll see this is our slip plane. So that's it. You can click close here. Now our slip plane has been defined, the entry and exit ranges has been defined. So we are all done for the analysis. You can save this project in case before running the analysis. I will write it as basic example. Okay, so now you can start the analysis. So once all the analysis will be run, the results will be available here. So you can see that our analysis has been done, and you can see that various factors of safety are being shown here, and you can see that if it has been sorted, the least factor of safety is 2.071. And what you can see is you can go to see the critical slip failures here. These are the critical one, and if you click one by one, then it will show you about the various slices that the columns that have been made for the slope failure plane. That is the traditional method being used in the Mohr. One thing that you can see is you can go to view and you can go to the column information. So for all of the slices that have been used in the analysis, you will be using this basic shear and the normal shear force. For each of the slice you will have these, and you can visualize one by one about the various So that's it about our today's example. So that's it about our today's video. We have tried to solve the example, this example, and we have come up with a factor of safety. That's how you do the slope stability analysis. So in the next video, what we'll be doing is we will be using the slide rock science slide software to do the slope stability analysis, and then we'll compare the factor of safety in both these modules.